Assalamualaikum. We are Group 5 WW1. We'll do a presentation for the subject industrial topic ELE672. And our presentation is about the production of extra virgin olive oil by using the implemented SCADA in the Malaysia. Extra virgin oil is extracted entirely mechanically from the olive fruit. As a summary, the process is begin with the pressing the whole olive fruit and extracting the oil from it. The olive oil is famous in the Mediterranean diet due to its high content of phenolic and volatile compound with the promoting and sensory properties in it. There are a few steps in producing extra virgin oil, and the most important one is the melaxation. The melaxation is using the melaxer, and it is actually the process of agitating the olive paste in milk temperature in the melaxer for about 30 to 45 minutes. In our project, we are created the melaxer that implemented with the SCADA system. And by using the SCADA system, it will control the temperature and gas concentration as well as the duration of the mixing. It is to produce high quality extra virgin oil.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Atira binti Maksupri and I will explain the problem statement of our project. So basically, it is common to know that every process in producing the product, there must be some limitation. So in this project, it's known that there are some limitation in producing the extra virgin olive oil or EVO during the melaxation process. So basically, the product need to be ensured in a good quality. So the problem is it is hard to ensure the quality of EVO as there are many variable parameters need to be controlled, such as time, temperature, oxygen concentration in the melaxer itself. So, in order to get the high quality of EVO, the producer need to know the right temperature to operate. So, besides, the melaxation process also need to be operated at the mild temperature for 30 to 45 minutes. So, in other words, the producer need to set the exact time and temperature to operate the melaxer. So, in heading toward the 4.0 industry, it is such a nuisance and complicated for the producer. So, therefore, to solve the problem, by applying the SCADA in the melaxer, it can be ensured the best condition and control the variable parameter to produce the high quality of EVO. Next, we move on to the objective of our project. The first one is to develop an improvement of system for extra virgin olive oil by implement the SCADA in the melaxer. And the second one is to create a ladder diagram for a SCADA module to allow melaxer to monitor the parameter management such as oxygen or nitrogen gas in the virgin olive oil production. And the last one is to evaluate the performance of the melaxer system in terms of high quality extra virgin olive oil production.
So now let's continue our presentation with electrical wiring diagram. So for our electrical wiring diagram, we have 4 input which are start, stop, push button, temperature and also oxygen sensor. And then for our output, we have 7 which are red LED, green LED, agitator engine motor, boiler, gas valve and also oxygen transmitter. So now let's move to design part. So generally in our chemical industry, there are a lot of mixing process occur in their production, and the equipment normally used is mixer. But in our project, we want to produce olive oil. So for olive oil, the mixing process occur is known as melaxation process. And as you can see from the slide, this is the design of melaxer system. So the process starts with the crusher where the olive fruit will be crushed and turned into olive paste. The agitator will start to rotate to mix the olive paste. The temperature of olive paste for malaxation process must be within 23 degrees Celsius until 25 degrees Celsius, but there is a research state that at temperature 25 degrees Celsius is the best temperature for olive paste, as it will produce a good qualities of olive oil. So to ensure the temperature of our olive paste at 25 degrees Celsius, we have heater to heat up the paste. Other than that, the concentration of oxygen level in olive paste is also important to ensure the quality of olive oil that we produce is good. So during the process, the oxygen and nitrogen gas will be injected into the olive paste, and at the end of the process, the oxygen sensor will detect the oxygen level in our product before the product undergo another process. So from this slide, you can see there is a LED. So when the oxygen sensor detect the oxygen level at 55 milligram oxygen, the green LED will show. Next, I will pass to Jalila to present about ladder diagram and HMI.
Thank you, Diana. So now I'll be explaining regarding the ladder diagram, human-machine interface, and also the functionality of our automated malaxer system for extra virgin oil production. So the ladder diagram is created using the Teams4 software, then HMI is created using the Web Form Studio. So based on the picture, you can see that the total tag number used in our system is 35, and the address type is used as an internal variable for all the input and output. And this is our ladder diagram where we use Teams4 software. So there are 15 rounds being implemented in order to complete the process successfully. And we use this software in order to compile and connect it with the SCADA system that is available in our UITM laboratory. So the next process, we start the simulation process. As you can see, when I started to push the start button, M1 will trigger motor, which is the agitator motor machine in round 2, where the agitator will start spinning to mix the olive paste. It was set for 15 seconds in timer 1, and at the same time, heat and also gas valve also being triggered by M1 as mixing procedure compromise heating and gas injection. As you can see, gas valve have been opened in round 6 for the injection process for 10 seconds. Then the oxygen sensor will trigger M3 output. So based on the output, if the value reach 55 mg of O2, then it will trigger LED in round 9 after the motor and heater stop. So the LED will run for 10 seconds, and after 10 seconds, it means that the first cycle of the mixing process in the malaxer is completed. We show our process that is focused on our HMI. And so this is our process, and I would like to explain that we also implement counter 1 for 6 cycle at round 14, where it will be based from the 3 status from the LED. We also put a reset counter so that when it reach our set value, it will reset back to 0, and it can be run continuously for our process of automated malaxer system for the productions of olive oil. So I guess that's all for me, and I would like to pass it to Zulaika for the conclusion. Thank you.
For the conclusion, to wrap, the technology will provide a lot of benefit to the people if we use it right in accordance of its aim and purpose of the invention. This project would ensure a systematic, efficiency and appropriate production of EVO among the agriculture industry. There are some limitations producing the extra virgin olive oil EVO during malaxation process. It is hard to ensure the quality of EVO with variable parameter management, time, temperature and oxygen concentration in the malaxer. So by the implementation of SCADA module, the production of EVO will help a lot to obtain the good and quality product. It helps to organize the system monitoring, able to handle automated control of industrial processes and machines of producing EVO. SCADA will also help to implement event and alarm notifications, and for sure reporting the progress of the system conducted. Instead of reducing the times and manpower in producing it, any circumstances of problem can be avoided caused by human errors, as the system itself will monitor and manage the process in the Melexer. By implement the system, it is better to pay for the worker's salary instead of paying the maintenance, which high number of costing. It has big potential for the system to compete in the market of EVO production based on the research conducted in the proposal. The system implemented is preferable as it eco-friendly without any kind of pollution produced, either from the production itself or the product of EVO. Even though the system has an attractive design and the report showcased the basic design of the system to be made the use of SCADA to control the function of the system. We really put a hope for the success of this production by EVO. With the implementation of SCADA module would be a great help among the olive oil and agriculture industry in Malaysia and other countries.